Hello, welcome everyone. Welcome to a new virtual tour of the European Southern Observatory, also known simply as ESO. My name is Farid Char, and with the producer Felipe Zurita, we are going to be your guides on this journey through ESO's La Silla Observatory. Well, from my part, I am one of the tourist guides of the Paranal Observatory actually, but I have been working in astronomy outreach and education for more than 15 years. And of course, I can answer several questions about astronomy in general and La Silla Observatory. So, but today I am not alone, as I told you already. I am with Felipe, so Felipe will be our producer. Hello, Felipe. How are you?
Hello, Farid, and hello, everyone. My name is Felipe Zurita. I have a degree in astronomy, and I love sharing science and astronomy for people of any part of the world. Today, I will be the producer for this online tour, and I'm excited to bring your experience. This is a virtual experience. Every Saturday, have a virtual tours in La Silla or in Paranal. So feel free to leave your questions about astronomy, about the virtual tours, the virtual tour today, and leave in the comment box. So come on, Farid.
Okay, thank you, Felipe. So yeah, I also would like to join you with these virtual tours, taking astronomy directly to your home or wherever you are. So remember, you can send your questions or comments through this streaming, and Felipe is going to collect your questions and comments, and we will have some time to answer them during this virtual experience. Okay, so you can use the comments section on Facebook or YouTube. Okay, so also don't forget to share this experience in case you like it, and you can share simply using the buttons of share on Facebook or YouTube. Okay, so we are going to start with this virtual experience with La Silla Observatory. And the first thing I want to do is to tell you about the organization. So in this case, ESO is an intergovernmental organization composed by 16 member states. Its headquarters are in Germany, and Australia is also part of ESO as a strategic partner. So in this case, Chile is the host state and home to all ESO observatories. So since the 60s, and with the purpose I mentioned, ESO chose one of the best places on the planet to carry out astronomy, the Atacama Desert in Chile. So at that time, Chile had started a site exploration campaign to attract international observatories such as ESO to our country. So in this case, Chile offered land and ESO chose the area with the better conditions. So the mission of ESO is to design, build, and operate astronomical observatories. And what for? To enable important scientific discoveries and foster cooperation in astronomy. We are going to take a look at another picture to see the ESO's observing sites in Chile. So first we have the Paranal Observatory, and this observatory is home to the Very Large Telescope, or VLT, that is currently the most advanced visible light telescope on the planet. In the future, the Paranal Observatory will also host the Extremely Large Telescope, or ELT, which will become the world's largest visible light telescope. And near there, uh, there will be another observatory called the CTA, that's an array of telescopes for the detection of gamma rays. Then we have the Chaknantor Plateau, the site where the ALMA and APEX radio telescopes are located. ESO participates in these radio astronomical observatories with its international partners. And finally, we have La Silla Observatory, the site you will be visiting today. This was the first observatory built by ESO in Chile and 2,400 meters above sea level in the region of Coquimbo. We will go there virtually during the next hour. Okay, so let's travel to La Silla Observatory. So looking at our planet, we start this journey by land in Europe, since I must mention that ESO is an European organization. So on this map, outlined in white, we can see the different ESO member states. Chile is the host country and home to all ESO observatories. So to see the sites, we will travel to the Chilean mountain range. And as we move over the Atlantic Ocean, let me tell you more about ESO's mission. To give you an idea, ESO tries to devise which type of instruments are needed to study the universe, and then will design the pieces, builds and operates the telescopes, and responding to observational requests from all the planet. So therefore, encouraging cooperation in astronomy. Okay, we are almost there, and we are going to look at a very amazing mountain. And you will see first a mountain range with domes. And you need to pay attention at the shape of the hill because maybe it will remind you of something, perhaps a horse saddle. In fact, the mountain itself and the observatory later were named after a saddle for horse riding. So this is La Silla. Okay, so in this case, over the years, ESO, Selassie Observatory, has become the perfect viewpoint for studying the universe. Okay, it was chosen by the astronomical community as an observational site at the beginning of the 60s. La Silla enjoys a large number of clear nights per year, a still and dry atmosphere, and dark skies far away from artificial light sources, and mean light pollution. So as we can see the names of the different telescopes on the road, for example, the ESO 1 meter Schmidt, we have other telescopes there, the NTT, the New Technology Telescope. So you will see the different facilities there. The CEST, is a former radio telescope in La Silla. And then you will find another ones, the Swiss 1.2 meters, Tarot, another instrument, the visitor center, and the ESO 3.6 meter telescope in the mountaintop. Okay, so in this case, the observatory was officially inaugurated by ESO in 1969, and some of the telescopes in the mountaintop are now out of service. So currently, 10 telescopes are in operations, and two of them are operated directly by ESO. The other telescopes, several of which are robotic, belong to other institutions with ESO providing facilities and the required support. Okay, so a few moments ago we were able to visit to do this virtual, uh, let's say, flight over the observatory. And but now I am going to show you some details about the observatory um, with this beautiful picture. Okay, because here in this in your screen at this moment, you can see the mountaintop of La Silla, and I am going to show you a general overview of this place. So you can see that several telescopes are visible from here. You can see the mountains in the background. You are looking at the west horizon from here. You can see the sunset, and you can see that we are in the middle of the Atacama Desert. So this observatory has been working for more than 50 years and is the first observatory built by ESO in Chile. This is the former CEST radio telescope, and we are looking at the east direction. with the mountains in the back. So as you can see, it's a beautiful place, of course. And well, in this picture in particular, it's a little bit cloudy, but we have several clear nights per year, of course. Um, and we will show you actually in another part of this tour how La Silla, basically a picture of La Silla at night. So you will have the chance to take a look at the night sky from La Silla in this virtual tour. Okay, so we are going to start this experience visiting the first observatory, the first telescope in the mountaintop in chronological order. So we are going to visit first the ESO 3.6 meter telescope. You will be able to appreciate the difference in the domes and the dimension of the enclosures, considering that the telescopes themselves are practically the same size. So as I told you already, we are going to start this virtual experience by chronological order of inauguration. So the first telescope we are going to visit is this one, the ESO 3.6 meter telescope. Okay, so let's go inside. Okay, here we are. So as you can see, this is a huge telescope, and you can see that the dome is very big. This is the 3.6 meter telescope, but is also called the 360 by the staff at La Silla, because the name refers to the mirror's diameter. Okay, 3.6 meters or 360 centimeters. So, for example, I can show you the dome from here. It's very big, and please remember this telescope is from the late 60s, so it's an old facility, but it's working, of course, and making a lot of important science. And now I am going to explain a little bit how this big telescope works. So back in the mid 1970s, it was one of the largest telescopes on the planet. Currently, it hosts an exoplanet hunter. The name of this instrument is HARPS. This is a highly specialized instrument. It's used every night to search for other planets outside our solar system. Now, what do you notice about the dome from the inside? Well, as I told you already, it's huge. The altitude from the first floor to the dome is 25 meters, and the whole structure is equal to a seven-story building. So everything seems small here when we compare with the telescope. For example, can you see anyone over there? Well, here we have a person. Can you see? I am going to do a close-up, and you can see that there is a person there. So this reference will help you to understand or to distinguish the telescope and compare the size, for example, with a person. So you can see that this is a big structure. Now, we are going to identify some important pieces of this telescope. And in order to do that, I am going to show you a picture, this one. So we are going to explore a little bit some important portions of this instrument. Okay, so the first thing I want to show you is that in dark blue here, we find the structure supporting the telescope itself. So this is basically the mounting of the telescope. The mounting works as a huge structure supporting the telescope, and is including several systems to provide the power, such as electricity, of course. And on this arm, parallel to the Earth's rotation axis, the telescope moves to follow objects in the sky during the observation. So This is the mounting of the telescope. Now, in this area, in light blue, here, we have the telescope's body holding the 3.6 meter or 360 centimeters main mirror and the secondary mirror. Now, where's the main mirror? The main mirror is not visible from here because it's covered by its protection system. I mean this black structure. This is a system of tabs which open and close to protect the mirror from dust or moisture when the telescope is resting or in the parking position. Now, in the black tubular structure here, in the upper part, we have the secondary mirror. And this mirror will collect light from the main mirror. I mean, the light will reach the primary mirror first. It will be concentrated and reflected to the secondary mirror. So the light will be reflected again and will be reflected that way to this hole in order to um, send the light to the instrument, to the main instrument. Okay, so basically the light is sent to the instruments through this hole, and well, and what is the instrument? Well, the instrument in this case, HARPS, the exoplanet hunter, is not visible here because it's completely isolated in another room in a different floor of this building. So the 360 began operations in 1977, and from the beginning it represented a challenge for engineering and for ESO as an organization. So the European astronomy was gathering talents from several countries to build an optical telescope in the 4-meter category. This is the largest and most advanced category that existed at that time. Now, why was such a large telescope needed? Well, in astronomy, the objects are analyzed through its light. The more light we collect, the more we can learn. In this case, a bigger mirror will capture more light and therefore more information will be available. So we will be able to see fainter objects and smaller details. Now, how do you think this telescope, this big telescope, is moving at night? We are going to show you a quick video to show you the movement of the telescope.
It have a slowly movement.
Yes, so this is basically how the telescope is moving. It's very impressive, of course. So this is what happens every night. The telescope has to move to uh, to to reach a different object in the sky and to start following the object. Okay, so a mirror for astronomy is not just any mirror because its shape and surface must be perfect at the scale of fractions of thousands of millimeters. So to achieve this in the 1970s, an extremely thick mirror was manufactured with 53 centimeters thick on average. But this also implies an extremely heavy mirror. Okay, so the mirror of this telescope weighs 11 tons. This is the equivalent of 2 African elephants. So if we want to build larger telescopes, we need to find other solutions. So how was the next step taken? We will see it later with the NTT. Okay, so this is more or less the general overview of this telescope. So Felipe, I don't know if we have any questions so far because um, we can
As
answer some
we
questions
have
before going to the next telescope.
we have much greetings from India, from Netherlands, from the of the North, Denmark, We have a lots of countries seeing us today, Finland, and I found I one question. Lagdar asked, the sky was filled with satellites. I noticed that many of the images showed the path of these satellites. And it occurred to me how observatories like your address this problem in their image. The problem of the satellites in the astronomical image.
Yeah. Well, the the short answer is that we cannot we cannot solve this problem because the satellites are still there. Now, the important thing is that a telescope, by definition, the field of view of a telescope is very small. So when you are looking at the sky with a telescope, you are looking at a very small portion of the sky. So, yeah, this is totally different when you look at the sky with your eyes or with binoculars, for example, because you are looking at a big portion of the sky. And of course, if you have any satellite or any other disturbance, yeah, you will see it. But if we are observing with a telescope, a very small field of view, yeah, the satellites can appear, but not always. But anyway, the astronomical community is aware of this problem
Mhm.
because we will have more and more satellites in the sky, and eventually, yeah, this could be a much bigger problem. So the solution for now, or some way to mitigate this problem, is to try to um, uh, convince some, the companies doing this kind of satellites to at least have the satellites with some kind of, I don't know, coating with less reflection of
Mhm.
light to avoid to see this kind of bright trail, affecting the astronomical pictures. But the satellites will still be there. So for now, it's not a big issue. As I said, the field of
But
view of a telescope is very small, and for now, the best way to address this problem is to try to, um, to find a way to create this kind of satellites, but with some kind of material or composition that does does not reflect too much light, okay, affecting the observations. That's it.
that's right. I know a little solution, but it's not the solution of the big problem. About the in the first match is you have a satellite course. You can wait until the satellite that passed to take another picture of the same part of the space, and later over over or pose over put over the other image to clean the satellite route. So yes, this is a big problem. Um, I have another question. Snowy asked, how many people are allowed in this chamber, and how do you keep it clean from dust? Dust is the commonly problem in the Atacama Desert. Um, in La Silla is it, it has about around 30 30 people's work in all of these telescope, and the problem of dust and snow problem is always all days, but the operators maintain clean all weeks the telescope, the mirrors. About 2 weeks, it cleans the mirror of the telescopes, cleans the zone around the telescope. So it's not a big problem about the dust. So this is the question for now. We need to move the next step. Uh, is a nice telescope called NTT. That's right, Farid?
Yeah, sure. We are going to move to the next telescope. By the way, thank you very much for your questions.
Mhm.
We are going to answer them later if you have more questions. We are going to move now to the next stop, and the next stop is this telescope in the background. We are going to visit NTT. Okay, so we leave the inside of the 360 behind, and before our next stop, the NTT, I would like to highlight the differences between the domes. Because keep in mind that both telescopes have almost the same mirror diameter. So the NTT was inaugurated in 1989. It has a small and very compact octagonal dome with a system of flaps. This represented in its days an evolutionary leap in the construction of telescopes, since it allowed hosting instruments in smaller and lighter structures with improved airflow on the inside. So basically, the big and complex domes, like the 360, are now a thing of the past. Okay? Because now we have more modern and advanced enclosures for the telescopes in a way that we can make a more compact dome and more efficient to host the main telescope. Okay, so and in this case, for the case of the entity, this kind of flaps allow the air to flow smoothly, reducing turbulence and preserving the sharpness of the pictures. Okay, so with this introduction, we are going to enter now the NTT. And here we are. This is the new technology telescope. You see? If you remember the structure of the 360 telescope with its huge dome and how small the person look inside, well, in this case, this building is practically attached to the telescope. So it's part of the same structure, you see? And if we stand in front of it, we will look approximately like this size. You see, you can see a door here, so you can imagine more or less the size of a person just in front of the telescope. Um, so the telescope mounting is also completely different. Here, the entire building spins around 360 degrees. Okay, so you can see here the building and how this building is attached to the telescope. I will show you from the other side, and it's like this. You see? So this is what happens here. Now you can see the main mirror in the on a pale color round structure, right? I will show you. I will do a close up here, so you can see the mirror. This one. This is the main mirror of the NDT. This disc is the mirror, and we can see that it's reflecting some light. So do you remember the 53 centimeters thick mirror from the 360? Well, the NTT mirror has almost the same diameter as the 360. In this case, is 3.58 meters to be precise, but it is significantly thinner. This mirror is only 24 centimeters thick, and it is also much lighter. In this case, it's the equivalent of just one African elephant, because the weight is 6 tons. Okay. Now uh, to keep the perfect shape of the mirror, the concave shape, as the telescope moves, there is a system of actuators or pistons below the mirror. The system is enclosed inside the box that you see just below the mirror. I mean, this thing. Okay. We have 75 actuators going up and down to keep the perfect shape of the mirror. This system is controlled by a computer, and we call this system active optics. The active optics system was developed by ESO and represented a significant technological advancement in the construction of the next generation of telescopes in the 10-meter category. So the active optics has been applied to all large modern telescopes, including the VLT, the Very Large Telescope at the Paranal Observatory, and will be incorporated as well in the upcoming Extremely Large Telescope, or ELT, that right now is under construction in a mountain near Paranal. This mountain is Armazones. Now, what about the staff? What about the scientists working for this kind of telescopes? Well, um, around 30 people are working in La Silla on different telescopes and doing different tasks. The scientific and technical staff are working from the control room of La Silla Observatory. So they are not here, they are not inside of this telescope, and they are not inside of the 360. They are located in a different place, and this place is located in a building quite far from here. So we are going to take a look at a short time lapse of the people, of the scientists working from La Silla during the night. We have a quick video about this.
Yes, we have a video about quick the discovers. I know
No,
what.
I mean the people working from the control room.
The water. Sorry, didn't hear.
Okay, thank you. So here you can see the people working from La Silla. I don't know, Felipe, if you can help me to know what workstation is for the NTT and which one is for the 360.
Yeah, sure. And the left part of the control room is a part of NTT telescope. Oh, sorry. Let me show you again here. The left part of La Silla control room and the part of the color closed people is a NTT telescope, and the right side is the 3.6 telescope. The people with the dark clothes are operators, and in the color clothes are visitors, astronomers. This is the part of the video you can see. The control room is directly in the mountain of La Silla, but far apart of the telescope. It's not inside of the telescope. This because the modern instrument have a have um, have a much detection of light or infrared light, so the human body have a heat that radiates infrared light, so the instrument of the telescope detect it and blind the observation. So for that reason, the people come to the control room in in the far part of the telescope. The process for you stay there is a long way, about 1 year 1 year before you stay here. First, you need to write a proposal, observation proposal. So next, you need to send to the HQ of the ESO quarter in Germany to revise the proposal versus the other proposal of the astronomer on the same night. So the best proposal, the ESO give a 9 hours. So later you can go to the observatory. This is a long pass. So if you see these astronomers in this short, this astronomer have a proposal 1 year before the control room video. But we
Yeah,
have another video, right?
yeah. We are going to show you in a few minutes another video because, as you said, Felipe, this is the work from the control room in from La Silla, but all this work from La Silla, from Paraná, from the ESO sites, eventually will have a result, and this result will be probably a scientific publication and maybe a discovery, maybe something very very useful for the advancement of science. So, in order to show you to our visitors something like a summary of the main scientific milestones from all ESO sites, we have a short video to show you some of the most important scientific uh,
Discourse.
discoveries are milestones from all the ESO observatories. So this is something like a top 10, and we're going to show you this short video with you right now.
Let's start.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, The star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, that was the top 10. I hope you like it. But we have something else. We have an extra, something like a bonus track. If you can put the additional video, please, Felipe. This is a discovery from a few years ago. In 2019, a team of astronomers were able to capture the first image of a black hole. The Event Horizon Telescope, in this case the EHT, an array of 8 ground-based telescopes distributed across the planet, coordinated by an international collaboration, achieved the first direct visual evidence of a supermassive black hole and its details. So the image reveals the black hole at the center of Messier 87, a massive galaxy in the nearby Virgo galaxy cluster. This black hole is 55 million light years from Earth and has a mass 6.5 billion times that of the Sun. Okay, so I hope you like the top 10. The discoveries achieved by ESO and the scientific staff behind them are truly amazing. Okay, now I will show you something. I will show you an interesting
The other side.
new perspective. Excuse me, Luis? Yes?
No, here.
Yeah. Now, we are going to show you something very, very impressive because, as I told you before, a few moments ago, the night sky from La Silla is very, very impressive. In this particular picture, we can see the night sky from La Silla Observatory in a clear night, and you can see that the sky is very, very, well, starry, and with a lot of details to explain a little bit. So, for example, in this case, I want to show you some interesting objects. In first place, we have a very popular constellation here next to the horizon. This constellation is visible from both hemispheres, the northern and southern hemispheres. This is Orion. In the mythology, is a hunter, So the Great Hunter with three stars somewhat aligned here, representing Orion's belt. So Orion is visible, as I told you already, from both hemispheres. You can see all those stars with the naked eye, I mean the bright ones here. And there is another important feature here because next to the three stars aligned forming Orion's belt, we have this thing here, and this is the Great Orion's Nebula. So this is a star forming region, and you can also see this with your naked eye, but of course it's much more impressive when you try to look at this with some binoculars or even a small telescope. So this is what happens here. This is Orion, and is one of the most popular constellations in the night sky. Okay, next to Orion, if we look here, we can see this star, and this star is the brightest star in the sky. Its name is Sirius. Okay, so this star is well, it's very easy to recognize, of course, and the constellation of Sirius, Canis Major, is the name, is in the mythology one of the hunting dogs of Orion. So basically, the constellation related to Sirius is connected in the mythology to Orion. Okay. Now, as you can see in this area in general, you can see a lot of different stars. Those stars are forming something like a path of light here because this is actually one of the arms of the Milky Way, our galaxy. Okay, so from our perspective, we see the Milky Way and this arm of the Milky Way as something like a band of light across the sky. Okay, because we are inside of this disk. It consists of around 200 billion stars and huge clouds of interstellar gas and dust. We can see the later as dark clouds that cross the band of light. We can see some uh, red clouds made of hydrogen because this is the simplest and most plentiful element in the universe. Okay, so basically the stars are made of hydrogen. Now, by looking through the Milky Way, we find two strange objects similar to clouds right here. We can do a close-up here, and we can take a look at this. So what is this? These are the Magellanic Clouds. The Magellanic Clouds are not clouds exactly. They are galaxies. They are irregular galaxies, and they are satellite galaxies of the Milky Way. So in this case, the Magellanic Clouds are visible only from the southern hemisphere. This one here is the large Magellanic Cloud, and this one there is the small Magellanic Cloud. The name is because this refers to the first records from Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So at that time, he recorded this kind of objects. This recorded this kind of objects like clouds, but they are actually galaxies, so they are not clouds. So this is what happens here with Magellanic Clouds. And next to the Magellanic Clouds, we have something else. We have a very popular constellation here. This is the Southern Cross. The Southern Cross is the smallest constellation in the sky. This one is visible from the southern hemisphere, and you can see that, of course, it resembles a cross. Now, why this constellation is also useful? Because there is something in the sky that is called the South Celestial Pole in the southern hemisphere. The South Celestial Pole is basically a point in the sky where is that is basically a projection of the um, south geographical um, uh, pole in the sky. So when you look at this point at night, the stars appear to revolve around this point. Now, how we can find the south celestial pole in the southern hemisphere? Because in this hemisphere, we don't have any bright star here because the south celestial pole is around this area. So the best way to find this point, we have two ways to do it. We can uh, imagine a triangle using the Magellanic Clouds. So this is one vortex, this is one vortex, and this is the other one. So if you do something like this, if you create a triangle using the Magellanic Clouds, in this position more or less you have the South Celestial Pole. And the other way to do it is to use the Southern Cross. You can project the Southern Cross about 4.5 times using the longer stick. You need to extend the longer stick. And so if I do this, like 1, 2, 3, 4.5, more or less, is like this. So the South Celestial Pole, as I told you before, is a projection of the South Pole, of the Earth's South Pole in the sky. And if you look to the horizon, uh, I mean, outlining a line to the horizon, this point of the horizon is basically the south cardinal point. So this is why it's so interesting. Okay, okay, and just to summarize and to finish this navigation of the night sky, we can show you that from this perspective, from this picture, you have the 3.6-meter telescope, and behind you have the center of the Milky Way. The center of the Milky Way is our galaxy, and this area of the center is wider, is more right, and is better to look at this area in during the winter months in the southern hemisphere. So, for example, May, June, July are good times to observe the center of the Milky Way because it appears all night in the sky, and you can enjoy a lot of different objects and nebulas and so on. So this is what happens here. This is what happens in the night sky from La Silla. It's a beautiful, beautiful night, as you can see here. So that's why we have this view, this important observatory here in the north of Chile. Okay, and to finishing this virtual experience, I want to show you some important um, important
Back
pictures
to the
here. Uh, yeah, I want to look at
back to
the.
the La Silla.
Excuse me.
Back to La Silla 3.6 in night sky.
Oh no, I think I
I
have it.
here.
Yeah, yeah, yeah. So from this perspective, we have again the 3.6-meter telescope, and from this perspective, I can show you the road to the other telescopes, and the same road will connect all the telescopes, including the 3, and including the 3.6, including the NTT. It will connect all the telescopes, and it will end with the hotel, because we have a hotel in La Silla, and all the ESO staff, the visitor astronomers, etc., they can stay here. So we are going to finish this experience with a short visit to the ESO hotel. And this person right here is the photographer in charge of all the beautiful pictures I show you during this virtual tour. So this is the ESO hotel. The ESO staff can stay here. And from this perspective, I can show you the sky is beautiful, and you have the center of the Milky Way just above you. So this is what happens usually in winter months, May, June, July. and this is a contrast if you compare with the northern hemisphere. In the southern hemisphere, you can see all the Milky Way about you, including the center of the Milky Way. So this is, of course, beautiful, and that's why many astrophotographers like to come to the north of Chile to take these kind of beautiful pictures of the stars. Okay, so we are almost finishing this virtual experience, but I think we have time to answer the last questions. So, Felipe, do we have additional questions?
We have two two last question. The first is interesting about the La Silla have a SETI research. I don't know. No, La Silla don't has a SETI research, but the principal research of La Silla is about the exoplanets, and it used the 3.6 telescope for find to find the exoplanets and habitable zones. So this world of exoplanets helps to set the research to find intelligent life in other parts of the galaxy. So this is the first question. It's very interesting about the aliens. The other question we have about about a clarified is if any have if ESO have any program to engage school students. You can find the ESO point RG in the web page to find the program for students, for academics, for anywhere, for anyone to how to learn how to use the telescope for about astronomy. So you can visit our page ESO.org to find more information. And about that page, you can also visit you can visit these observatories too. With reserve the in the page, you can reserve 1 day in a Saturday for Paranal or La Silla. And we have another last question for you. This is true. There are a type of habitable zone in our galaxy, like a habitable zone in the solar system. What do you think?
Um, yeah, as far as I know, there's a concept that is called the galactic habitable zone, and because from some perspective, in this portion, it's possible that some planets with proper conditions to sustain life can appear. In this case, what makes this area habitable is factors like metallicity of the stars in that area. Uh, so basically, to summarize this thing, um, the galactic habitable zone in the Milky Way is something like more or less like in the middle of the, let's say, the ring of if we imagine the Milky Way, if we imagine the like an middle ring in the Milky Way, yeah, there is something like like a portion of the space when some stars can maybe be more suitable to get some planets to support life. But in any case, when you want to find planets with actual life, the planet itself has to be in a position, in a location that is not affected by the star, the host star, because the star, of course, is emitting energy, and and you want that your planet is not too hot or too cold, right? So even if you have a planet in this kind of habitable zone in the Milky Way, your planet has to be in a good distance compared with the host star.
So this is a last question I have today. Thank you for leave your question. Any question is a full question. Any don't is a full question. Sorry. So remember, leave your comments. You can find us every Saturday for virtual tour. Today is in La Silla. The next week is in Paranal, in Spanish and English. One week in Spanish, 1 week in English. So this is the end for today. Thank you for watching us, and I leave you free to.
Yeah, sure. Thank you very much, Felipe. So thank you very much to all of you for joining us during this virtual visit. I would like to remind you that all the visits, information, pictures, and material are available on the ESO website, eso.org. So the next tour, as Felipe said, will be Paranal. We are alternating Paranal, La Silla, English and Spanish. So that's it. We hope you enjoy this tour. And on behalf of ESO, we thank you very much for joining us today. So thank you and see you soon.
Goodbye.